Welcome back, boys and girls. Today is a reminder that metaprogramming is still one of the best things that you can learn as a software engineer. We're going to take a look at things like reflection and expression trees to effectively solve a problem that would otherwise make you go something like, oh, why do I need to write so much code to solve this problem? The task is easy but monotonous. You would have to create a lot of code in order to solve this problem. Well, I'm here to tell you that for some of these problems, the solution can actually look a lot smaller and a lot more scalable as well. Before we dive in, don't forget, if you're enjoying the video, leave a like and subscribe. If you have any questions, make sure to leave in the comment section, and I have a C# course that is out. If you would like to know C# as I did, highly recommend you take a look at it. With that, let's go ahead and get started. So here we have an example of data sanitization. So for example purposes, we have two very simple models, a human model and a story model. They have a couple of properties, and the real thing that I want to focus on is the name or the title property. And what we are trying to do is to sanitize the name or sanitize the title. Let's say that currently what we're trying to do is just change the name to uppercase and change the title to uppercase as well. If we actually want to do this, we will go ahead and create our class that, I don't know, maybe let's call it sanitize for now. We would give it two static functions where we would take our data, we would take the name, and then we will go ahead and try to sanitize it. We would then do the same for the other data type. And let's not forget to iterate through all of the stories and sanitize all of them. So human story and sanitize it. There we have it. Now if we take sanitize, we go over here, and before we print our stuff, let's go ahead and sanitize the human. This should also sanitize all of the stories. Not too complicated up until you realize you have hundreds, thousands of these, many different properties, many different ways that you want to sanitize them. And every single time a new sanitization rule comes out, you need to update everything. How do you solve this problem? If you have 1,000 engineers, each engineer can write one sanitization rule, you're done in a couple of hours. If you have 2, 3, 5 engineers in your team, writing 1,000 different mutations that iterate through these classes, which may be complicated, may not be complicated, may be interlinking, etc., that may take, months, perhaps years, perhaps forever. We don't have that kind of time to check every single class. We write a program that scans our code and figures out everything that needs to be sanitized and creates functions for us. That is what we're going to be covering today. So here I have a sanitize object class. So sanitize object because that's the responsibility that we have. What we're going to do is we're going to create a new sanitize object. Let's go ahead and instantiate this. We're not going to pass anything good in there for now. All we're going to say is, look, this is what we want to do to a human, and this is the interface that we're working with. So instead of calling this function over here, I want to go ahead and actually call it this way. What do we actually put in here? And for this, we'll just quickly dissect what we have here for the interface. We're passing some kind of object. Based on the type, we extract the mutation object, and then we're converting it back to an action of a certain type. Now, there are things that you can do here to circumvent this casting, and you can have an additional layer on this generic dictionary, but I am trying to remove as much detail from here just to make sure that I get the idea across. There are also strategies that you can pass in here where you're saying, okay, I want to sanitize this human, but I want to sanitize it one way or another way or third way, so you can interchange the strategy of sanitization, which would again add another level to your dictionary. But we'll have a bunch of types for which we want to create mutations. Let's go ahead and create public static sanitize object, and we're just going to sanitize it right here. We're going to create it, and what we're going to create it based on is a collection of types that we actually want to generate these mutations for. So over here, let's go ahead and return a new sanitize object where from the types we can go ahead and select, or rather actually just to dictionary, where the type, and I'm not sure what's happening there with the tooltips, but here we will just go ahead and create a mutation. Again, you can't see the code because the tooltip is amazing. The method, we don't have it, so let's go ahead and create this method as well. So we have our incoming type. We want to create a function which is going to mutate this type later at runtime. Here we're just defining a program which is going to create all of those various ways that we want to mutate these objects. Because we're going to be working with expressions, it's gonna help if we kind of have a little bit of space where we can type out the things that we're looking for or what we're trying to create. So some kind of type is going to come in here. And perhaps we're going to try to have a body that looks like this. Let's remove this space over here. And on here, we want to put properties that we're looking for. Okay. So in our case, this will be name in the case of a human and the title in the case of a story, where then we want to execute this type of logic to upper or to uppercase, depending on what it was called. So let's double check over here. Yeah, it's just to upper. And as I said, this is going to vary. So the property that we're going to execute, this is just a variance, right? So we need some kind of condition based on which we want to extract this property. So let's have a look at this. We have a type that is going to have properties. So let's go ahead and get all of its properties for each. Property info that is going to match some kind of condition. We want to generate a statement. We ultimately also want a list of statements, and because we're working with expression trees, I'm preemptively going to say that, look, these are our mutation statements, new list. And if we match that condition, we want to go to our mutation statements and add something to it. There are tons of things that you can do over here. We're going to do, again, the most simplest thing. You can pass some kind of interface here, some kind of checker that is going to say, okay, based on this property info, does it meet all of these conditions to go into a specific strategy of mutation? That's how far you can take it. We're not going to be taking it this far. We're going to be hard coding a condition of, is this property type equals type of string. This is going to help us just match any property, which is a string, which will then allow us to just say, okay, we want to take this property, we want to upper it and reassign it. So on expressions over here, we will have an assign property where on the left, we will want our actual name or title property information. And on the right-hand side, we want an invocation on this function. So let's put a comma over here. And first of all, let's get access to this property over here. The way that we're going to reach our title or our name is based on this parameter. The name over here doesn't matter so much. All that we're saying is there is going to be some kind of parameter of a specific type, of this type that we're creating over here. The way that we create a parameter is there is a parameter expression, which we're saying, okay, create us a parameter of this type. So this is our parameter. Let's put a little bit of space over here. Actually remove this space. So we have the parameter of this type. This parameter is going to have a property. We can start surfacing this property over here or over here. I'm going to tell you that it's better to surface it over here because you're going to try to reuse it between the if statements, which are going to check this property. So you actually already want the reference to it. So the property is going to have a name, and then you can also reach this property through the expression API, where you're going to say, I want this parameter, and then from the property info, I want to get the property's name, and this is going to get me my property expression. Okay, param name, I was doing this on the wrong variable, but what this is going to give us is about yay much, and this exists both here and here. Okay, if we do something along the lines of this, where we're saying to the property, assign a property, we have about yay much. So nothing is actually happening. So what we actually want to do is take this right-hand side property and apply the function to upper to it. But here we have our assignment. We're going to take this assignment, add it to the mutation statements. And before we actually start doing the mutation, let's go ahead and build up the body of the lambda. So if we go to the expression and we're going to try to create a lambda expression, where first of all, we're going to have a body and then a parameter. So let's put a comma over here. I'm going to try to scroll down a little bit here. We're going to have the parameter. This is going to be a lambda. And then for the body, we can have an expression block. So a code block to which you can pass a list of expressions that should be executed in that block. So we have the block. We take the mutation statements. We place them in here. And that's pretty much it. You can leave them here or just supply them as the body. And the lambda over here is going to be the same thing as this, okay? For now, let's go ahead and just return the lambda at the end. We can just put the return statement over here as well. Let's remove this, format the code, come back to program CS, and at the top over here, instead of creating this way, let's go ahead and create it here, where the types that we're going to supply is going to be type of human and type of story. The way that you surface these types, you can also use reflection to mark up your classes that you want to go through sanitization, or if you mark up the individual properties to say what kind of sanitization these properties can go through. If a class has any of those markers, you can surface them this way. And again, the place where you're doing this setup is before your application actually starts. So you only pay the price of generating all of those functions at startup time rather than during the runtime of your application. Okay, now that we have this, as I said, the toUpper is not yet invoked. So what we should see is the application not crash, but the application should just run and nothing should happen. Cool. So, and that is exactly what is happening over here. Now what we want to do is take the property that we have over here and call a function on it. So we're going to go to expression. There's going to be a call function where we can have some kind of instance on which we're going to either call a method, or if there is no instance and there is a static method, there is an overload for that as well. But we are going to double check if toUpper is indeed a method on a string, or it's a static method or an extension method, and it looks like it's a method on the string. So let's come back to the sanitization object. We're going to take the property, which is our instance, and we're going to call the function that is on the string toUpper. And of course that the instance was meant to be working on an object rather than on an expression, I think. So let's take a look at it again. No, so it's actually instance, method name, type arguments, which I have none, and then a params of expression array of arguments, which we also have none. So all I have to do is pass a null here and it should be fine. Once we have this, this is going to be to the toUpper expression, right? So let's go ahead, place this over here, open up the terminal, run the application again. And we're still getting nothing potentially because the object that gets created over here isn't actually an action of some kind of type. So there are things that we can do here, but just to verify that that is indeed that, we're going to go down here real quick. We're going to store this in a variable result and just return this here, return result, breakpoint here, quick debug. And it looks like right over here we are actually generating an expression of func human string where the last statement is the uppercasing and then the assignment. So we don't actually match this over here. So we never actually enter it to mutate this in the first place. So let's stop the demo over here. Let's see if we can do anything to help the type of this. If we go to expression lambda and we take a look over here, we have the delegate type that we can supply. All right, so we will get type of action, and this is going to have empty generic parameters. This is going to be our action. We will then want to make generic type, and we're passing in this type over here, and this is going to be delegate type. We're going to pass that as the first parameter. So in case you've never done this before, what you're doing is first you're saying I have an action of something, and then whatever this type is, it's going to create that type. So if it's an integer, it's going to create an action of integer type. So it's just going to create this type definition. All right. We're going to pass that over here, and now result should be just an action for a human or a story. And looking at this right here, looks like it is. So let's go ahead and continue the application. We're doing the same for the story. Continue the application again. And again, this doesn't get mutated because we're not actually compiling it. All right. Once we have compiled it, let's go ahead and run it again. And there we have it. So now we're uppercasing Bob. The big problem that we have here is that human is actually a complicated data structure and it has other nested classes in it. And this could be a common story. This could also be a recursive story where we're saying, look, a human can contain a story and a story can contain a human, then it's circular. What do we do in those situations? That's something that potentially you yourself might need to figure out. I'm not going to give you all of the solutions here, But here is another thing that you can do. Let's just take the if statement and we're going to solve the problem for just the story. Else, if the property type we can check is generic type, and we're going to check that the type get a generic type definition equals type of list or enumerable. We're basically checking, is this a collection? If it is, we want to get the type that is sitting inside of there. So gen type definition, we want to go in there, and here I believe it's get generic arguments. This should only contain one, and this will be the element type. And now that we have the element type, we can create a mutation for this specific element type. So we go to the create mutation function. We're going to pass the element type to it, and this is going to be the element mutation. Once we know how to mutate the individual element, what we want to do is we want to go through a for loop and apply this mutation to each individual element. Okay, so for this, we're going to go ahead and create a helper function, public static void mutate collection. And this collection is going to be of a specific type. We're going to get a list of t, or an enumerable of t. The first argument is going to be that we're going to get a list of t, so some kind of collection. And then we want to have a mutation to that collection. So this is going to be our mutation function. And here we can actually write regular C#, right? For each element in the collection, let's go ahead and apply the mutation to this collection. And again, this implementation might look a little bit different for you if you have records. Perhaps what you're going to have to do is you're going to say, okay, for all of these, create a new collection and just return it from here. And then here you're going to have an assignment instead of just a simple method invocation. Let's go ahead and get a reference to this static method. So mutate collection method info. We're going to have our type of sanitize object. And on here, we want to get a method with a name of mutate collection. And by the way, if this is going to be private static, you may need to supply different arguments on here for the bindings, right? So bindings, default, instant, public, private, read-only, etc. Maybe read-only might not be here, but you get the picture. Basically, if you're not reaching your method, watch out. You may need to supply some of those binding flags. So here's the method information. It is static. So on the expression, we're going to call this on an instance, which is going to be null. We're going to call this method. We're going to have a type argument of the element type. So let's go ahead and provide a new list of types. Put the element type in here. And then the actual parameters. Let me spread this out a little bit. The first one, the list, is going to be the individual property. And then the mutation that we're going to be applying, well, that's the mutation that we have just created for this type. And we're going to place it over here, okay? And the current problem that we have over here is that this doesn't actually compile because all of these need to be expressions. Property is an expression, element mutation isn't actually an expression. This gets returned as an object because that's what we compile over here. Let's go ahead and start returning the expression again. We're going to say that, look, this lambda is going to return a lambda expression. That is what we're returning from here instead of an object, okay? This is going to stop compiling over here. What we're going to do is we're going to just go ahead, compile our lambda, and in the end, convert it to an object. And this should quiet down, all right? As we go over here, I'm actually realizing that we cannot specify this argument. There is no overload for having type arguments over here. So not to fret, we can make generic method anyway, where we supply this type over here, right? So let's take the element type, and that's going to be our generic method. We're going to remove this, and there we have it. We have our call, and this is going to be the mutation call. We're going to take our mutation statement, place this over here, take the mutation call, place this over here. And now if we run our application and we're getting some kind of weird error over here, which happens on line 57, which is when we go into here. So I'm just going to say that, okay, we're passing something really weird to the element type. So let's go ahead, put a breakpoint over here. Let's go ahead, debug this. And it looks like that the logic here is just flawed. I don't want to get the generic argument of the generic type definition because it doesn't actually have a generic argument at that point, at the point of definition, right? So what I want to do is probably go to the property type and get the generic argument here, which is then should be first. Let's go ahead and execute it. The result for this should be story, right? So let's go ahead, take about yay much. We're gonna get the generic arguments from the property itself because it's a list and not the generic argument definition. Let's go ahead, get rid of this. I'm just gonna stop this application because a lot of things are flying about everywhere. Let's go ahead and bring up the terminal again, clear it and run. And there we have it. If we also want to go ahead and mutate an individual story, so if we take this, place this over here, we're going to call this story 3, and I'm going to give this some kind of bogus title. We're going to take the sanitization method, put story 3 into there because we did specify the story as a thing over here. We're going to take the console write line, take story 3 over here and output its title. Let's go ahead and see if it has been uppercased, and it has been. So now if anytime in the future I go ahead and create some kind of new object, let's say this is a dog and it has a nickname which also needs to be sanitized, I can actually just go ahead and say, look, this dog needs to be sanitized. We're gonna go ahead and create this dog, so new dog. Its nickname is going to be whatever, Bobby. Pretty standard nickname to me. Let's go ahead, sanitize this dog, and then go ahead and output its name. So let's erase maybe about yay much, grab the nickname, run the application, and there we have it. So Bobby gets uppercased as well. So as I said, you may be wondering, well, what if I just don't want to mutate all of strings? I want to mutate individual strings. Again, I'm going to come back to sanitize object over here. I'm going to put more emphasis on this if statement. This should be something that you supply from the outside where you're saying, look, I want to create these mutations with these strategies, and this individual strategy should have this condition for these properties on why I want to mutate them. So again, this only makes sense if you need this kind of sanitization. If you have a bunch of data that looks weird and you need to go through all of that data, it's many different classes. Accommodating all of those classes will be a lot of work. So you create something like this where you can say, okay, I have these type of classes with these type of properties, which each individually have these type of constraints amongst which they should be sanitized. So for this if statement, you can say something like, and if property information name equals nickname, okay? If we run this, hopefully only Bobby will get sanitized, all right? So instead of a hard-coded if statement over here, you're gonna have a strategy. You're gonna supply this property info to that strategy, and if that strategy triggers, you go ahead and create a mutation for this strategy, which you can then surface during this sanitization method. So instead of creating new sanitizers for all of these objects, you're working with much more succinct structures, which basically say only which objects, which properties, and how they should be sanitized. And this will be it for this video. Thank you very much for watching. If you enjoyed the video, don't forget to leave a like and subscribe. If you have any questions, make sure to leave them in the comments section. If you would like the source code for this video as well as my other videos, please come support me on Patreon. I'll really appreciate it, and a big and special thank you goes out to all of my current Patreon supporters. You help me make these videos. As always, thank you for watching. Have a good day.